Okay, alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the hard problem maximum employees to be invited to a meeting. Its index is 2127. Okay, actually this problem has appeared in today's contest like LeetCode let me weekly contest 274. Like the first three problems are pretty much easy, so I'm not interested in talking about that, and the last problem is actually problem related to graph theory, so I thought to discuss it with you guys and tell you the best solution of this problem and how what is the approach to solve such type of problems. Okay, so if you are not if you have already not read out this problem at least once, so I will recommend it to read it out to have a better understanding. Otherwise, no problem, I am going to explain it with the help of examples and all that. Okay, so let's begin. A company is organizing a meeting and has a list of n employees, okay, waiting to be invited. They have arranged for a large circular table capable of seating any number of employees. Okay, so there is a circular table and we have to fix employees around the circular table with certain conditions. Let's try to understand that condition. Employees are numbered with this. Each employee has a favorite person. Okay, so every index, or you can say every index varying from 0 to n minus 1, has some is referring to some another index also, which is actually the favorite person of that particular employee. So each employee has a favorite person and they will attend the meeting only if they can sit next to their favorite person at the table. Okay, and the favorite person of an employee is not themselves. Okay, so let's try to understand this with the help of a diagram. Okay, so let me just choose a bolder color first. Okay, yeah. So there is a circular table right over here, and there are some employees. Okay, like employees, there are total n employees. Okay, and varying from 0 to n minus 1. And this employee, suppose there are 4 employees sitting on this table, and this employee will sit on the table only and only when the favorite person of this employee is either to the left of it or to the right of it, like any one. Okay, and there will be an array given to you. Okay, and this element will denote the favorite person of the first employee, favorite person of the second employee, favorite person of the third employee, and so on. So in other words, if you have been given this array and you can put all the employees on a circular table only and only when the condition will hold, and the condition is that this employee will sit only and only when this is the favorite person of this employee. Also, this person will only sit if the favorite person of this employee is either this or this. And this person will always sit in this circular arrangement consisting of 4 employees only and only when either this employee will be present to the left of it or this employee will present to the right of it. Okay, so there can be many ways to choose the employees. There will be n employees, right? And n is going to vary up to, you can see, 10 raised to the power 5. So either brute force is not going to be accepted anyway. Okay, so we need to find an efficient solution. How we are going to choose the maximum number of employees such that if we put all these employees on this circular table, then for every employee the condition is going to be satisfied, like for every employee. Okay, so how this is going to be done? Okay, so we will take an example and understand. First, let understand how we are going to maximize the number of employees. Let's pick up this 2212. Okay, so let me move on to the next page. So 2 2 1 and 2, we need to choose maximum number of employees and place the employees on the circular table such that for every employee the person sitting next to each other must be the favorite person of the current employee. Okay, so what is the favorite person of the 0th employee? The favorite person of the 0th employee is the second employee. Okay, you can see it, the value referring over here is 2, and this is the index at 1. Note that I'm using a 0 based indexing. Okay, so index 1 is saying that my favorite person is the employee 2. And what is about this? And index 2 is saying that yeah, my favorite person is the index 1, and index 3 is saying that my favorite person is the index 2. Okay, so you need to first map these values Okay, now we need to choose the maximum number of employees. So if you are creating a graph with nodes as the employee number, then you can easily demonstrate how the maximum number of employees we can choose. Okay, so I am just mapping this problem into a graph problem. How the employee number is going to be the graph nodes, and the edges, note that I'm going to use the directed edges. Okay, I'm going to use the directed edges. So if over here you can see, and it is saying that at the 0th index its favorite person is the 2, so there will be a directed edge from employee number 0 to the employee number 2. Okay, so let's create a graph according to this given data. Okay, so let me just choose another color to be like very much efficient. Okay, so it is saying that there will be a employee 0 who is saying that my favorite person is the employee 2. Okay, and again employee, for employee you can see employee 2, it is saying that my favorite person is the employee 1. Okay, and for 1 it is saying that yeah, my favorite person is the employee 2 again. And then for 3 it's saying that my favorite person is the employee 2. Okay, so you are going to choose a maximum number of employees and place them around the circular table. Like this is the circular table, and you have to choose some employees right over here. How you are going to choose that? So let's choose a random arrangement of employees. Like I am going to choose like I will choose 0. If I will say yeah, I'm going to choose 0, I will place employee 0 over here. If and only if I am going to do this only and only when there is some employee just right next to each other, next to the employee 0, which is the favorite person of the employee 0. You can see the favorite person of employee 0 is the employee 2, so I must have to place 2 over here. Okay, so I can place 2 over here only and only when the employee right next sitting to the employee number 2 must be the favorite person of the employee 2. You can see the 0 is not the favorite person of the employee 2, and the only favorite person is the employee 1. Okay, so I must have to put a 1 over here. Okay, so 0 is saying that yeah, my favorite person is already present. 2 is saying that yes, my favorite person is already present. Okay, what about the 1? You can see that 1, I'm talking about this one. 1, like what is the favorite person of this one? Can this be 0? No, it cannot be 0, because it is saying that one's favorite person is the 2. Okay, but you can see when I placed the employee number 1 over here, the node 1, it has already been satisfied that one's favorite person is 2, which is already present right next to the right to the employee number 1. So it is a valid arrangement. Okay, so this arrangement is a valid arrangement, and the number of employees present over here is 3. So 3 is our answer. So can this be a maximum answer? Of course, this can be the maximum answer if we are not able to find some another arrangement of employees which is going to give the more answer than this one. Okay, so like there can be many arrangement. If you put like in place of 1, if you try to put 3, you can see that this will contradict the problem statement that for every employee in the arrangement there must be a favorite person right next to the current employee. It is not satisfying, so that will be wrong. Okay, so this is a valid arrangement. So how you are going to do this problem? Okay, so first thought that will strike into your mind is like we have to convert this problem into a graph problem. So the very first thing is like convert this problem into graph problem and draw a directed edge. But this is not sufficient. You have to be like much more thinking skills. Like okay, so let us draw first a certain arrangement of employees. Okay, so there will be some employees over here. Okay, suppose that these employees are around the circular table. Okay, and you are going to draw directed edges. Like no, you are going to draw the you are going to claim that this is a valid arrangement. Okay, so how you are going to say that? Now let's try to understand this one. Let's say I am going to fix this node I, where I is the employee number. So this employee can only be placed over this table if and only if the favorite person is right next to this one, or the favorite person is right next to this one, right? Okay, so let's say that the favorite person is right next to this one. Okay, now employee this node can only be present over here if the, you can say, if the favorite person is present right next to each other, either this one or it is present over this one. Okay, so let's say that it is present over here. Okay, now for this employee, either it can be present over here or it can be present over here. So you can see that the pattern is like there can be a cyclic graph consisting of directory. Favorite person is this, 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 and so on. So you can see that there is a cyclic graph. There's a cyclic graph of consisting of directed edges. So if we convert this problem into a graph problem and we are able to find a cycle in this graph such that the cycle length is L, then our answer can be L. Maximum answer can be L. We need to maximize our answer. So can this be a sufficient? No, this is not a sufficient. How this is not a sufficient? Because each time when I've considered this node, I say that favorite person is just sitting right next to the each other. Okay, right next to the current employee. So there can be the possibility that this edge is not like this one and it is like this one. There can be possibility, right? So let's try to understand that possibility. Okay, so let me just erase the edges and suppose these two edges are present. Now for this one there can be this arrangement. Okay, so if yeah, so this is the arrangement. This is satisfied, the favorite person is right next to each other, and this is also satisfied, and this is also satisfied. What about this one? Yes, this is the like major thing. What about this one? Like favorite person can be sitting right over here, and favorite person or can be sitting right over here. There are two cases. Okay, so how we are going to deal with that? Suppose this is the case present over here, and again let us draw a random observation. Okay, so this is present over here, and for this it is also present over here. Okay, and for this it is present over here, and for this it is present over here. You can see that yes, now all the employees has been satisfied. The arrow is going to denote that favorite person is present in that arrow. Okay, so now you can see this arrangement is valid. Yeah, it is valid, but the graph is not a cyclic graph. There is one key trick that is present over here. And what is that trick? You can see that if you fix this node, like this node and this node, there is a cycle of length 2. Okay, so this is a cycle of length 2, and all these nodes that are present over here, you can see that form the arms of these two nodes. Okay, form the arms. If you're not observing this clearly, no need to worry about. So let me draw this one. Okay, so where is my cursor? Yeah, and there is this one. Okay, and all the nodes that are present over these two nodes are the arms present over here, like this one. Okay, and here also there is some nodes. Okay, like this one. All these are present like hanging to these two nodes. You can see that there is a sequence of nodes hanging to this node, and there is a sequence of node hanging to this node. Okay, so there can be multiple sequence of nodes hanging to this nodes, like there should be a linear chain. Okay, so this is a, like whenever you are finding a circular table having such type of arrangement, this is valid. Okay, now if this is valid, then any combination of such arrangements is also valid. Okay, how this is going to be done? Let me just move on to the next page and explain it in a simpler words. So suppose there is two nodes and there is an arrow over here and there is an arrow over here. Okay, now this is the one of the arrangements and this is the one of the arrangements. Okay, and yeah, suppose there is also one another arrange like this one. So first of all, you need to understand that for every nodes consisting of two length of two cycle like this one, you need to find the length of longest arm present over here. This is 2, right? Yeah, this is 2, or you are going to find out this one. this is 3 length. The like for this one, the length of longest arm is 3. Length of longest arm is not going to be like 2. There is a length of arm of 2, but you're not going to consider this one. You are going to consider this one, the length of longest arm. Now what I'm saying is that there can be multiple such such arrangements, like this one, and this one, this one, this one. Like for this one, like for this arrangement, there can be multiple such type of arrangements, like of length of cycle 2, and the hanging arms can be of any length. Like this is the one of the arrangements, this is one another arrangement, but there is something common in these two arrangements. And what is that common? There must be a there must be a cycle of length 2. You can see directed in a directed graph, cycle of length 2 and cycle of length 2, and there are must be a hanging arm, must not calling it as must, there can be a hanging arm of length 0 also. So there must be a cycle of length 2, and the arms can be present to any of these two nodes, like over here or over here, and if the arms is present, you need to find the length of longest arm. Okay, now if you concatenate these two nodes, concatenation here is means like if you take all these two set of nodes over here, like these all set of nodes and these all set of nodes into one circular table, like putting all the employees in this circular table, then this is also a valid arrangement. How this is going to be a valid arrangement? Let's try to understand that. Suppose this is a circular table and there are nodes present over here. Okay, now you have a length of cycle as 2, like there I have drawn the length of cycle as 2. Now there is a arm present over here and there is a arm present over here. Okay, now you can see that this is a I have actually drawn this arrangement. You can see I have actually drawn this arrangement. Yeah, so there is a length of cycle 2 and the arms are present to the respective nodes. Okay, now you can see I can combine such type of arrangements one or more times. Okay, so what I'm saying is that yeah, the remaining set of nodes that are left over here are these 4 nodes. How we are going to combine? Okay, so I am saying that yeah, I am going to place this one and place the length of cycle 2 and arms like this one, and yeah, I'm going to do like this one. So this is actually representing another arrangement. So the length of arm would be this one and this one. You can see I'm talking about this arrangement. Now can you claim that this all the employees are placed in this table are actually the correct arrangement? Yes, you can see the correct arrangement. For every employee there must be a favorite person sitting right next to each other. Let's try to find it out whether we have some valid arrangement or not. Yeah, checking this one. Yeah, the employee is present, favorite person is present right next to each other. It is valid. For this one, yes, it is present right next to each other. For this one, yes, it is present right next to this other each other. And this one also, you can see the arrows. Yes, this one also, this one also, this one also, this one also. Yeah, this is a valid arrangement. So concluding, like arriving to the conclusion, I am going to say that you are going to have two type of arrangements in this graph. Okay, so I am going to talk about answer. Okay, so your first answer would be find all cycles, in directed graph. Find all cycles in this directed graph. Find like actual length, you are finding out the length, and you are going to maximize your answer as answer equals max of answer and this length L. Okay, and the second thing is like find all cycles of length 2. Okay, there is a cycle of length 2, and you are going to find all arms maximum length of left arm, maximum length of left arm, and maximum length of right arm. Then your answer would be what? Answer equals max of answer and let's say the left arm L1 plus right arm L2. So the first arrangement would be like this one, this one, this one, this one, and it is a cyclic one, everything is satisfied. Or the second one would be like this one or this one, and there are some arms hanging over here. It can be of any length, you need to maximize it. So if you're not understanding it right now, no need to worry about. Let's start to code it up as fast as possible, and along with I'm going to explain. Okay, so we are going to code it up. So I'm going to just copy the template and I'm going to use my editor to do that. Okay, yeah. Yeah, actually, it is like I'm being familiar with this one, so I used this. I'm going to use this. Okay, so first of all, I will just favorite dot size, and the like first we need to find out the cycle, right? Cycle finding. So what we are going to do is first of all we will take a adjacency list, adjacency of n, and we need a parent vertex of n initialized with -1, and later on we will also use the in degree. So first of all I'm not going to mention it over here, so just n and I plus plus, and next thing I will use to do is adjoint of I dot pushback favorite of I. Yeah, so there is a directed edge from I to favorite of I, right? And the next thing I need to use is like vector bool visited of n, and there is a recurring stack mentioning over here. If you're not aware about finding the directed cycles, you can refer the article present on Geeks for Geeks. That is the best one I can say. Okay, so let me just first mention answer as 0, and we will find all the all the connected components. Let's try to find out the cycles. If it is not visited, then we will just recur dfs I passing visited, passing recurrence, and passing adjacency, and also passing the answers. Okay, and where I passed the parent vertex information, yeah, I think it is correct. So let us define DFS function, which is taking the parameter as v, and it is also taking the visited one vector bool and visited, and it is also taking the recurrence one, and it will also take the parent information, and it will also take I'm not defining it globally because actually I don't like over here in the LeetCode defining globally because it doesn't have a test cases mentioning over here. Yeah, I need to use int adjacency, and finally maximizing answer. Okay, so I will use viz of v barabar rec of v barabar true. So okay, actually this function is finding cycles. Okay, so if it is already visit like if it is not visited, just visit them. Parent of u barabar v, I need to mention the parent also, and if it is not visited, u viz, and passing a recurrence parameter, parent also, adjacency also, and answer also. And if it is visited, I need to maximize the answer, like maxima finding the length of cycle. So I will just mention it over here. Find the length of cycle. So you need to write on else if also, and if it is still present in this recurrence, then we are going to have a cycle. Okay, so I'm going to find the length of the cycle. So vertex will be v, and current answer will be 1. Okay, so while vertex is not equal to u, then current plus plus, and vertex exactly matches with parent of vertex, we need to go up. Okay, and if we are done, maximum of answer and correct. Let me just cross check it out whether I am going to do the correct operations or not. Yeah, parent u is reg par adjacent answer, finding the length of the cycle. Yes. Yeah, I think I've done the correct one. So answer will store the maximum answer for all those cycles, length of cycles. And yeah, I think I've done something wrong. I need to just rec off v because it like it is now vanished from the recurring stack. Yeah, I have done the correct. Yeah. So now I need to find the length of the arms. I'm going to use the topological sorting. So you cannot use the topological sorting also. You can reverse the edges, directed edges, and then you are going to perform a simple DP. But here I am going to use the topological sorting. So in topological sorting using Khan's algorithm. Khan's algo. So what it will do is like where is my open board? Yeah. So what it will do is like let me just explain in a simpler words. Like suppose we have this one and this one, this one, this one. So first it will push all those nodes which have in degree as 0. Each time it will decrement the in degree of the child nodes, and whenever the in degree of child nodes becomes 0, then we need to just push back into the queue again. Okay, if you're not aware about the topological sorting, no need to worry about. Just read the article of topological sorting and then you are getting familiar with that. Okay. So for now, let's move on to this one. You need to use the DP here also. Okay, so as I've already said, I need to know the in degree of every nodes. Okay, so it should be like in degree of favorite of I plus plus. Okay, so I need to use the queue and I need to push all those nodes. If there is the in degree as 0, then q dot push I. Yes, I think I've done so far as correct. And yeah, now how we are going to do proceed further. So there will be a DP. Note that this is for finding the length of the arms ending at this current position. Okay, so DP of n and passing as the 1. Now we need to find every arm, so I will do a topological sorting, simple. Push q dot pop out one of the nodes and find every adjacent node, decrease the in degree. So I will say minus minus in degree of u. If it becomes 0, then I will just push back into the queue because now the current processing works for this node. Okay, so dp of u also becomes max of dp of u and 1 plus dp of v. Okay, so yeah, I've done the correct one. So it should be like storing the maximum one. So if you're not understanding it, no need to worry about. Like for this one, it will what it will do is like it will have all the values initially initialized as 1, and initially this node will be present in the queue and this node. In the next processing, in degree of this node will be decreased by 1, and each time I'm going to do dp of u equals 1 plus max of dp of v. Okay, so it means that 1 plus 1, it will here it will be stored as 2, and when this node will come it will be stored as 2 plus 1 as 3. Okay, now it is you can also reverse the edges of perform a simple dp from like top down from these two current nodes. Okay, so how I am going to, so let's find all those set of arrangements like this one. So where is my, like all those arrangements having the arms. Yes, so like these arms, you can see this is one of the arms and this is one of the arms, right? So we have already found the maximum length of the arms, and we need to find all those cycles of length too. How we are going to find the cycles of length too? Okay, so it is very much simple. So you need to just go in this actual array and you will say if favorite of favorite of I exactly matches with I, we are going to find the length of cycle 2. Cycle as 2. Okay, so we are going to sum up all those length of arms. So sum plus equal to favorite of I and favorite of uh, wait a minute. Yeah, I think it should be like yeah, sum plus equal to what is the current node? Current node is I, so it will be dp of I and dp of favorite of I. dp of I with means this node. I think yeah, dp of I will be this node, and like its favorite employee is this one. So it will be dp of favorite of I means this maximum length of arm for this one, and for this one dp of I maximum length of arm is this one. Okay, if I am going to done with this, I need to divide by 2 because each time each pair of nodes is going to be counted twice. So I will be dividing by 2 and maximizing the answer as sum. Okay, and return answer. Let me just copy paste over here. Yeah, not sure about that whether I am going to get the, yeah, it is showing correct. Yeah, I've already submitted another one, but it was like using different methods. So, but now I am going to use a different method to explain you guys. Yeah, so runtime is good, and yeah. So, if you have any doubts, do mention in the comment section of the video. Also, I'm mentioning the topological sorting article and finding the length of the cycles, printing cycles articles. Okay, so if you have any doubts, first read over there, and if you're going to get some doubts, just mention in the comment section of the video. Thank you for watching this video.